Pakistan's devastating floods are the result of a lethal combination of specific climate systems, geography, and human error. To understand why these floods become so destructive, we must trace the entire mechanism from the mountains in the north to the Arabian Sea in the south. Every summer, massive weather systems begin forming around the region, creating the baseline for flood risk. The first is the monsoon system, carrying enormous water vapor from the Bay of Bengal. The second is westerly waves from the Mediterranean, bringing rainfall into the north. The third pushes up from the Arabian Sea as cyclones, creating massive atmospheric convergence. These systems interact to generate extremely heavy rainfall, characterized by the dark, heavy storm clouds often seen gathering over rural terrain. While this rain falls, rising summer temperatures simultaneously hit the northern mountain ranges. This heat rapidly melts snow and glaciers in the Himalayas, Karakoram, and Hindu Kush, creating blue-tinted meltwater pools at the base of these jagged glaciers. This extra meltwater routes immediately downhill, flowing directly into the Indus River system. This convergence of atmospheric moisture and thermal meltwater causes the Indus and its tributaries to swell, creating the country's baseline flood risk. Climate change has intensified this entire process. The physics are straightforward. For every 1 degree Fahrenheit rise in temperature, the atmosphere can hold approximately 4% more water vapor. More moisture in the atmosphere translates directly to heavier rainfall and more violent storms. Global patterns like La Niña worsen the situation by increasing cyclonic activity in the Bay of Bengal, pushing abnormal rainfall toward Pakistan. Researchers have also observed a nearly 100-kilometer westward shift in Pakistan's monsoon pattern. Because of this shift, regions previously considered safer, including Khyber Pakhtunkhwa, southeastern Punjab, and central Sindh, now face unusually intense rainfall. These climate multipliers mean historical weather models are no longer reliable predictors, priming the country for disasters that exceed its traditional baseline. Rainfall volume is only one part of the disaster. Pakistan's geography determines exactly how that water behaves on the ground. In the north, including Khyber Pakhtunkhwa, Gilgit-Baltistan, and Upper Punjab, the landscape is mountainous and steep. Rivers like the Swat, Kabul, and Panchkora flow through narrow valleys with sharp slopes. When intense rain falls here, the water rushes downhill at terrifying speeds, creating sudden flash floods and powerful hill torrents. You can see the kinetic destruction in the eroded riverbanks and the white water rushing beneath the foundations of concrete buildings. During the 2010 floods, the Swat and Kabul rivers recorded flows exceeding 400,000 cusecs, shattering the previous 1929 record of 250,000 cusecs. But the flood mechanism changes completely once the water reaches Sindh in southern Pakistan. Unlike the north, Sindh is mostly flatland with an extremely low gradient. Here, the Indus River actually flows on a raised ridge, meaning the surrounding land is lower than the river itself. The river is controlled by long defensive embankments built on both sides to hold back the hydraulic pressure. When those embankments break, enormous volumes of water spill into the lower plains. Because the land is so flat and sits beneath the river channel, the water cannot naturally return. This is why floodwater in Sindh often remains trapped for weeks or months, destroying crops and entire villages. Topography dictates the form of the crisis, destroying via speed in the north and via stagnant pooling in the south. Human activity has made the crisis worse. Rapid urbanization and illegal encroachments have severely reduced the natural carrying capacity of rivers and drainage channels. Near Nowshera, human settlements have reduced the width of the Kabul River by more than 50%. In Rawalpindi, the Nulla Lai drainage channel has shrunk from its original width of 50 meters down to only 23 meters because of encroachment. Similarly, the Ravi River Basin witnessed nearly 60% population growth over the last decade, increasing pressure on its natural floodplains. Deforestation removes the trees that naturally absorb rainwater and slow down runoff, forcing water to flow rapidly across the surface. Concrete roads and paved surfaces in expanding urban areas prevent water from soaking into the ground, overwhelming drainage systems never designed for such pressure. Infrastructure design creates additional bottlenecks, where highways and bridges act like artificial dams. Bridges on the M1 motorway between Peshawar and Murdan acted as a choke point, with insufficient drainage capacity causing severe flooding in nearby agricultural land. Finally, Pakistan lacks the water storage infrastructure to manage these events. Nearly 13 million cusecs of freshwater flow into the sea every year because the country lacks enough reservoirs and dams. Human development has broken the landscape's natural ability to safely route and store excess water. These weaknesses became visible during Pakistan's two historic megafloods. The 2010 floods affected nearly 20 million people and submerged 1/5 of the country, with economic losses estimated at $10 billion. The 2022 floods were even more catastrophic. In 2022, Sindh received 426% above normal rainfall, while Balochistan recorded 450% above normal rainfall. Nearly 1/3 of the entire country went underwater. Families were left to look out over endless brown floodwaters that covered the landscape as far as the eye could see. More than 33 million people were affected, and almost 8 million were displaced from their homes. Over 1,739 people lost their lives. Total economic losses reached approximately $30.1 billion, a disaster that may push up to 9 million more Pakistanis below the poverty line. Pakistan can no longer rely on temporary emergency responses alone. The country must adopt a modern system of integrated flood risk management. This includes removing illegal encroachments from floodplains, enforcing river protection laws, and building new reservoirs and dams. It also requires modernizing early warning systems with Doppler radars, improving drainage infrastructure, and investing heavily in reforestation. While floods are natural phenomena, the scale of Pakistan's destruction is ultimately the result of climate change, poor planning, environmental destruction, and decades of unmanaged development. Thank you for watching. Subscribe, like, and comment.